So hello everyone, in this video I am going to explain about the diagonal scale. So before starting the construction of diagonal scale, let's see what is the difference between the plane scale and the diagonal scale. So we have seen in the last video that the plane scale was used for the measurement of two units. Right? So plane scale was used for the measurement of two units. So we were doing the division of a line two times. So the first was the main division. So the first main division. Then again we were dividing the first division into the subdivision. So second was the subdivision. So this was the concept of plane scale. We were dividing the line two times. For the first, that was the main division, that was representing the first unit, and second division was for the subdivision, which is called, that was representing the subunit. So plane scale was used for measurement of two units. So we were doing two times, we were doing the line into equal number of parts. Now coming to the diagonal scale. Now diagonal scale is used for measurement of three units. So diagonal scale is used for the measurement of three units. Used for measurement of three units, right? So for the three units again, here we are going to divide the line into three times equal number of parts. So the first division that will be the main division, that will representing the first unit. Second division, that will be the subdivision, that will be representing the subunit. Third division, that will be the subdivision of subunit, that will be representing the third unit. So basically the point is, in diagonal scale we have to divide the line three times into equal number of parts, because we are going to represent here three units, right? In the plane scale we were representing the two units, so we have divided two times equal number of parts. But in the diagonal scale we are going to divide the line three times into equal number of parts. Out of the three times, the first two are representing the same thing which we have done in the plane scale. So the construction of the diagonal scale is similar to the plane scale for the first division, that is the main division, and for the subdivision, right? For the third division, that is the subdivision of the subunit. For the third measurement of unit, representation of the unit, we are going to add something in the diagonal scale. So that I am going to discuss today by means of one problem which I have taken. So the difference between plane scale and diagonal scale is, plane scale is used for measurement of two units, but diagonal is used for the measurement of three units. So now coming to the problem. So the problem is, construct a scale of 1 centimeter equal to 0.5 meter. So this is the relation given to you just for the finding the value of RF. So we all know what is RF. So RF is the representative factor, and the formula for calculating the RF is length of the drawing, that is the length of drawing upon actual length. So construct a scale of 1 centimeter is equal to 0.5 meter. It means drawing length is 1 centimeter. So length of the drawing is 1 centimeter divided by 0.5 meter is the actual length. So that is 0.5 meter. So convert meter into centimeter. So multiply by 100. So that will be 1 centimeter upon 50 centimeter. This will be cancelled out. So RF is 1 upon 50. So this is the first basic requirement to calculate representative factor, which is represented by RF, that is equal to length of the drawing upon actual length. So the value of RF is coming 1 upon 50, because we are dealing with the reducing scale. So RF is less than 1, right? So which can read meter, decimeter, and centimeter. Now here we have to measure meter. This is the first main division, right? Decimeter, this is the subdivision, this is the second unit. Centimeter, this is the subdivision of subunit, this is the third unit. So we have to read here meter, decimeter, the centimeter. So we have to deal with the three units. So for that we are going to construct here the diagonal scale. Meter, decimeter, and centimeter. And long enough to measure 6 meters. So 6 meter is the value of L max given to you, long enough to measure 6 meters. So L max is given, that is L max, that is 6 meters. So this is the second basic requirement to find out the L max, which is already given 6 meters. Third basic requirement is to calculate length of scale. So length of scale that is equal to RF multiplied by L max. So RF is 1 upon 50. So multiply by L max, that is 6 meter. But we have to represent length of scale in centimeter. So convert this meter into centimeter. So that will become 1 upon 50 multiply by 6 into 100 to convert it to centimeter. So this will be cancelled out. So length of scale is 12 centimeter. So these are the three basic requirements, A, this is B and C, based on which we are going to construct our diagonal scale. So the first requirement is RF, so that is equal to 1 upon 50. Second requirement is L max, which is already given the problem, that is 6 meter. 6 meter is the L max value. Third requirement is length of scale. So length of scale is equal to RF multiplied by L max. So that will be 12 centimeters. So this is the calculation which we'll be using to draw our diagonal scale. Now coming to the construction of diagonal scale. So length of scale is 12 centimeters. So now I am going to construct the diagonal scale step by step. So I will be using not the actual data, but I will be using the approximate data, and I will be using this scale to draw the diagonal scale. But we have to use proper measurement and the technical instrument to draw the scale. So start with a line of length. So start with a line of length 12 centimeter. Right. So start with a line of length 12 centimeter because length of scale was 12 centimeter and L max that was 6 meter. So length of scale is 12 centimeter. So start with a line, draw a line of length 12 centimeter. Draw a line of length 12 centimeter. Now let's extend this line because again we have to divide into equal number of parts. Right. So now divide this line to 6 equal parts. Now this line is of 12 centimeter, but this line is representing 6 meter. As we have discussed in the plane scale also, the line will be of length of scale in centimeter, but that is going to represent the L max, right? So this line is representing the 6 meter. So if we want to represent single meter, if we want to represent 1 meter, so we are going to divide this line into 6 equal parts. So divide this line to 6 equal parts by means of graphically method. So how to divide the line to 6 equal parts? Draw an acute angle line. Draw a line of acute angle. Take a compass, right? Keep the needle at the starting point of the line, and if you want to divide to 6 equal parts, you will be giving 6 cuts. First, second, third, fourth. This is 5 and this is 6. Join the last cut to the end point of the line. So graphical method says that draw a line of acute angle, take a compass, give the 6 cut because we have to divide into 6 equal parts, join the last cut with the end point of the line, then take this line as a reference, and just plot the parallel lines. So again I am repeating, I am not doing the actual measurement, I am not taking the actual measurement, this is all the approximate drawing, but when you will be drawing, so please use the actual measurement and the proper instruments. Fine. So this is the 6 equal part of this line. So numbering, as we all know, numbering should start from the end of first division. So this is representing 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So this is the meter scale, right? So we are going to write here meter. So in capital letters, I will be representing here this is meter scale. Now meter work is over. Now coming to the decimeter, so we all know again we have to divide this first division into equal number of parts, that is based on the relation between the two units, and we know 1 meter is equal to 10 decimeters. So we are going to divide this first part again into equal number of parts. So So again I will be using the graphical method for the division. Acute angle line. So first, second, third, fourth, 5, 6, 7, 8, 9, 10. So I will be joining the last, right, and then dropping the parallel lines. So divide the first division 10 equal part. Now this is representing decimeter. So the reading number should be such that it should be start from the 0, but we have to move toward the left side. So this will be my 1, this should be my 1, this should be my 2, 3, 4, 5, 6, 7, 8, 9, and this would be my 0. Right? So this is representing decimeter. So where I have written the meter on the same line, I am going to write here decimeter. So this is my decimeter scale. So as we have seen that till now we have done the same procedure, we have followed the same step what we have done in the plane scale, right? So for measuring the two units, starting the two units, that is meter and decimeter, we are following the same steps of plane scale. Now coming to the diagonal scale, now we have to measure here centimeter also. So for that we need some extra construction here. So the steps, now I am going to add something in this scale so that we can represent centimeter here. So the first thing which I am going to add is draw a vertical line from the starting point of this line. From the starting point of this line, draw a vertical line. Draw a vertical line. You can take the length of line, you can take any length. You can take 5 centimeters, 6 centimeters, 7 centimeters, whatever you want. You can take any length of this line. So you have to draw a vertical line of any length. Suppose I have taken this length 5 centimeters. I have taken suppose 5 centimeters, you can take of any length. Then you have to divide this line into again equal number of parts. As I have told you, in diagonal scale we have to divide 3 times. First already we have done, this is the main unit or the main division. This is the second subdivision. Now third will be coming here. So this is again the division of subdivision. How many equal number of parts we have to divide here, that depends on the relation between these two units now. So we know 1 decimeter is equal to 10 centimeter. So we have to divide this line again into 10 equal parts, because the relation is 1 decimeter is equal to 10 centimeter. Again you can use the graphical method for the division. So graphical method now will be implemented like this. So draw a line, acute angle, again take a compass. So first cut, second, third, 4, 5, 6, 7, 8, 9, and this is 10. Last cut you have to join with the end point, then draw parallel lines. So this is the 10 division for the vertical, and numbering should be like this. This should be 1, 2, 3, 4, 5, 6, 7, 8. This should be 9 here, and this should be 10. Okay. So you have to take a vertical line of any length and divide that vertical line to 10 equal parts, because the third unit centimeter is going to be represented on that vertical line. Next step is complete the box. Next step is now complete the box. Complete the box and draw the vertical lines from the main division. Draw the vertical lines from the main division like this. Next, draw the horizontal line from this vertical divisions. Horizontal lines. So what I have done is I have just completed the box. I have just made a box, and then from all this vertical 10 divisions I have just dropped horizontal lines for this only first part. You can take to the entire this box also, or you can drop only up to this first line. Now coming to the main step. Now this is next step will be the main step of the diagonal scale. We have to follow. Now we have to apply here principle of diagonal scale. Now we have to apply here principle of diagonal scale. We have to apply here principle of diagonal scale. Now principle of diagonal scale says that you have to join the last point or the last division of the vertical line to the second last of horizontal line. So this is called the principle of diagonal scale. This is the principle of diagonal scale. So principle of diagonal scale says that you have to join the last point of the vertical line. Which is the last point of the vertical line? So this is the last point of the vertical line. You have to join this point to the second last of the horizontal line. Second last means this 9th is the second last of the horizontal line. Please be careful. You have to join the last to the second last. So this is a common step, construction step of the diagonal scale, which you have to follow in each and every problem. You have to join the last to the second last. What you have to do? First you have to draw the vertical line of any length, divide it into equal number of parts. In this problem we have divided an equal number of parts because 1 decimeter is equal to 10 centimeter. Then complete the box, then verticals and then horizontals. Then apply principle of diagonal scale, which says that join the last point to the second last. Okay, so I am applying the principle of diagonal scale. So I am going to join the last to the second last means 10 to the 9. So I will be getting a line. Which is inclined. So I got a line which is inclined in nature. That is not vertical. That should be inclined in nature. Right. So basically we are using the concept of similar triangle, which we are applying here in the diagonal scale. So you have to join the last to the second last. So you will be getting one line which is inclined in nature. Now take that line as a reference. From each and every subdivision, like from A. Draw parallel lines. Similarly from the 7, draw parallel. Similarly from the 6, draw parallel. From 5, draw parallel. From 4, parallel. All these lines are parallel to each other. So first we have to join 10 to the 9. So you will be getting one line. Based on that line, take that line as a reference and draw parallel lines from each and every subdivision point. From each and every 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. From each and every point you have to draw a inclined line that will be parallel to each other. Right? So first join 10 to the 9, take that as a reference and just plot the parallel lines with reference to that line. So there will be grid type structure on this first division. Now this grid type structure will be utilized for measuring this decimeter and the centimeter. How it is going to utilize that I will be showing you after that. So now this is called the diagonal scale. So as you can see here, this is the entire construction of diagonal scale. Now here you can read meter, decimeter and the centimeter. Now centimeter, this is going to represent centimeter. So here you will be writing this is centimeter. This is the centimeter reading. And where will the RF should be between the meter and decimeter part. So at the center we are going to represent here RF is 1 upon 50. So this is the complete diagonal scale now. Now what part is going to be highlighted? So the scale should be highlighted. Apart from the scale, what we have done the extra construction for dividing the line, like I have taken one acute angle line and then the parallel lines for the division, for the line division. Similarly, I have taken here acute line and divided into 6 equal parts. Similarly, I have taken a reference here for dividing 10 equal parts. So all this extra construction work on this scale, that should be light. And apart from that, the scale should be dark. The scale should be dark, it should be neat, it should be proper. So this is called the diagonal scale. Now how we are going to measure here 4.26 meter here. How we are going to measure 4.26? See, 4.26 means 4 is representing meter. 4 is representing meter, 2 is representing decimeter and 6 is representing centimeter. So how we are going to plot here? 4 is meter. So this is my meter scale, main division, meter scale. So 4, from here I will be taking this 4. So 4 meter will be here. So this is my extension line from the 4 meter, and this should be light. Again, this should not be dark, this should be light. So this should be light. 4 meter. 2, 6. Now the combination of decimeter and centimeter you have to plot together. How? 2, 6. Now inclined line of 2, just observe it. Inclined line of 2 is intersecting, inclined line of 2 is intersecting 6 at this point. You have to be very careful. Inclined line of 2 is intersecting the 6, 1, 2, intersecting the 6 at this point. So from here, from this point, you have to take extension line vertical, like this. So this is my extension line from this point, which is representing 0.26. 0.26. Extension line joined by means of dimension line. Now this is a dimensioning part, so you have to use this extension line and the dimension line with the proper arrowheads. So this is representing 4.26 meters. So in this way you can measure any unit, you can measure any suppose 4.26, you can represent any quantity here for the maximum value of 6 meter. You can represent any value for the maximum length of 6 meter. So this is called the diagonal scale. Again I am repeating the entire construction. So while observing the problem, the first work is to find out the RF, second is Lmax, and the third is length of scale. Then draw a line of length of scale, then divide into equal number of parts. That will be representing the first main unit. That is representing the first main unit. Now coming to the first division, again you have to divide into equal number of parts. That will be representing the second unit. That is called the subunit of the main unit, subunit. Now then drop the vertical line of any length, then divide again that vertical line into equal number of parts. Again the numbers of division, that depends on the relation between the units, and that is representing the subdivision of the subunit. That means the third unit. Then complete the box, then apply principle of diagonal scale. This is very important. We have to apply principle of diagonal scale, which says that join the last point of the vertical line to the second last point of the line. Then drop the parallel lines. Then complete a grid-like structure. Then you can represent what is asked in the problem. So this is the entire construction of diagonal scale. Thank you.